So obviously they want to try to get as much utility as possible. So for the consumer, you look at what your choices are and then you try to figure out what combination of goods is going to give you the most satisfaction. Okay, so consumers will choose an optimal consumption bundle, and that's going to give them the most satisfaction, so the most utility. Oh, the income divided by the new price. Okay, so in the table here, you now have information about utility. Now these are we're back to the coffee and books example. So these were the different bundles that the consumer could choose from. And now we're given the amounts of utility that they will get from the different quantities. So this is total utility. This is total utility. Now all you have to do is add these together so that you can figure out what's the total utility from the bundle. So 0 plus 70, 12 plus 62. Okay, and then it's very straightforward. They want the most utility, we look for the biggest number, and that will be right there. So bundle B will maximize their utility. Okay, so the last part of the chapter is just a slightly different way of thinking about how consumers make decisions. Because really, in reality, when you are at the store deciding how much to buy of something, you're not like making a table of all your different consumption possibilities and then figuring out total utility for each bundle, right? We don't do that. Usually in the store, what we're doing is we've got, like, say, two things in our hands, like, should I get this or should I get this? And what you think about is, well, how much satisfaction will I get from this? And then how much does it cost me? And then how much satisfaction will I get from this? And how much does it cost me? And so you're comparing the two, right? So, like, say, when you go to Costco or Superstore, for example, on the labels, like on the shelf, they've got like price per unit, right? And so you can see, how much am I paying per unit? And then you can think about, say, how much do you like the different goods? Like if you're trying to choose between, say, cashews and walnuts, right? You can think about the different tastes and then how much the different prices are. And so in the moment then, what you're thinking about is how much utility am I going to get relative to how much am I spending, or utility per dollar. Like if I'm spending my dollars on this good or I'm spending my dollars on this good, how much satisfaction will I get, right? So I think cashews taste better than walnuts, but they're a bit more expensive than walnuts, right? So you have to weigh that, that ratio, right? Think satisfaction to dollars. Okay, so this is about utility per dollar. Okay. So consumers try to maximize utility from each dollar that they spend. And so in that moment, when you're trying to decide between the cashews and the walnuts, what you're doing is you're figuring out a ratio of how much utility am I getting per dollar, like utility relative to the price. And so that's called the marginal utility per dollar spent. So you're figuring out how much utility will you get, but then how much will you pay for the good. Okay, so it's the additional utility from spending one more dollar on a good or service. All right, so the formula is just taking the marginal utility from the unit of the good and then dividing by the price of the good so that you're getting utility per dollar. Okay, so we're looking at the books and coffee example again, and we've got the same bundles as we derived before, and also we have the different amounts of utility that were on the previous page, and the prices are the same as they were at the beginning, $4 for coffee, $20 for books. Okay, so we're going to calculate marginal utility per dollar. So we'll start with the books, and we'll start at the bottom here, starting at 0, and then we'll work our way up the table. Okay, so we'll go from here to here. So going from 0 books to 2 books. Now, the marginal utility will be for 2 books then, right? We're going from 0 to 2. So those 2 books are providing 20 units of utility. And then we divide by the price, but it's the price of 2 books because we're going from 0 to 2. So books are $20 each, and so if we're buying 2 books, then that will be $40. Okay, and then we can simplify. So that will be 0.5 utility per dollar. Okay, so now going from here to here. So now going from 2 books to 4 books. Those next 2 books will provide an increase of 17 units of utility, divided by the price of the 2 books again, right? So again, we're going by a change of 2 books, which will cost $40. Okay. Okay, so 17 divided by 40, so that's 0.425 units of utility per dollar. Next 2 books increase utility by 37 to 51. That would be 14, and those 2 books will cost you $40. That's 0.35. So of course these numbers are going down because as you get more and more books, your marginal utility is going to be falling, but the cost is the same. Okay, next 2 books from 6 to 8, that will increase your utility by 11, 51 to 62. So 11 units of utility, those 2 books will cost you 40. Okay, 0.275. And last 2 books Those last two only increase your utility by 8. Still cost you $40 though. Let's be 0.2. Okay. So then you have to compare that to the coffee because what your decision is between the two. And what you want is to buy the good that's going to give you more utility per dollar. So you have to compare how much utility per dollar you're going to get from the books to coffee. So now we got to go through the same exercise for coffee. And so we'll start at the top now with 0 coffee. Okay, so now we're going by tens. So the first 10 cups of coffee give you 12 units of utility. And those 10 cups of coffee are going to cost you $40. That's right. They're 10 cups, they're $4 each. So that will cost you 40. Okay, so 12 over 40. 0.3. The next 10 cups of coffee increase your utility by 8, from 12 to 20. So you're getting 8 units of utility, and those extra 10 cups of coffee will cost you the same though, $40. Okay, next 10 cups increase your utility by 6, from 20 to 26, and cost you the same, $40. Next 10, 26 to 30, so that they give you 4 units of utility and cost you $40. 0.1. Okay, and then the last two only give you 2 units of utility, cost you the same. Okay, all right, so now you're going to compare the two. All right, so let's say you're comparing bundle A and bundle B. Now with bundle A, you're getting no coffee, but you're getting 10 books. And then in bundle B, you would give up 2 books in order to get 10 cups of coffee. Now, when you give up the 2 books, when you give up the 2 books by going from here to here, you're giving up 0.2 units of utility per dollar. But then you're able to buy the 10 cups of coffee, and those 10 cups of coffee are going to give you 0.3 units of utility per dollar. So you'd make yourself better off then by giving up the 2 books and getting the 10 cups of coffee, because what you're going to get from the coffee gives you more satisfaction than what you're giving up for the books. Okay, so because this is higher, 0.3 units of utility per dollar is higher than this, then you're making yourself better off by getting those 10 cups of coffee. Okay. But you would not buy any more cups of coffee because the next 10 cups of coffee only give you 0.2 units of utility per dollar. And to get them, you'd have to give up 2 more books, and you'd have to give up 0.275 units of utility per dollar. So you wouldn't do that. That would make you worse off. Okay, and then likewise, going down the table, you just wouldn't buy any more coffee because the satisfaction that you'd get from the coffee per dollar is way less than what you'd be giving up for the books, so you just wouldn't do that. Okay, so yeah, so you'd go from A to B, but then you'd stop there, which we already know from a couple pages ago that bundle B is the best bundle because it provided the most total utility. Okay, so yeah, so we know that the consumer will stop there at bundle B. All right, now the graph here is a bar chart, kind of like we were graphing in chapter 4, right? Bar chart or a step graph. Okay, so let's see. So these lines here, starting at 0.3 and going down, this would be for the coffee. So the scale here going from 0 to 50 for the coffee, marginal utility per dollar goes down. And then the other ones going up would be for the other scale, which is books. So going this way from 0 on the right side to 10 on the left side. And what you can do with this step graph is you can draw a line. Now, when you draw a line through a step graph, what you want to do is have a line that's going through the midpoint of each step. And now it won't be a straight line when you draw it. It'll be a bit curvy like that, but that's okay. And we'll do the same for coffee. Now, when you do that, what you'll see then is that those two lines might not be exactly, but they are crossing closest to bundle B. So we have an equilibrium here at bundle B, which we know is the best bundle. So at that best bundle, that's where we're getting the consumer's getting the same utility per dollar for both goods. So the marginal utility for coffee relative to the price of coffee is equal to the marginal utility for books relative to the price of books. And that's an equilibrium because if that weren't an equilibrium, if you were going to get more utility per dollar from one of the goods, then you wouldn't want to be at that bundle. You'd want to move and get more of one of the goods, right? But if you're happy there, that means you're getting about the same utility per dollar from both of them. All right, so this page is about this equilibrium, that we were just found on the graph, the equilibrium between the marginal utilities per dollar spent. And so that is the point that we all try to get to. Okay. And so then the last thing here is that this equilibrium point, or the idea that we always try to move towards this equilibrium, helps to explain the demand curve. So with the demand curve, we buy more if the price goes down, or we buy less if the price goes up. And you know that intuitively, but now this will sort of be the theory behind that. Okay, so we're going to use this theory about the equilibrium here and the idea that consumers are always trying to move towards this equilibrium, and that will explain why the demand curve slopes down, or it'll explain the law of demand. Okay, so in our example, the price of coffee was $4, and then the consumer would find this equilibrium point, or the combination where it's at an equilibrium. So that was $4, but what if the price of coffee falls to $2? So now the fractions are not going to be equal anymore, right? This was 4, but now it's only 2. So if this number gets smaller, then this fraction is now bigger, right? So now they're going to get more utility per dollar from the coffee, and what will they do? Buy more coffee, of course, right? And so then they're going to choose to buy more coffee, and as they buy more coffee, the marginal utility of the coffee will go down then, right? When we buy more of everything, the marginal utility will go down. And so then by buying more coffee, they're going to be moving back towards the new equilibrium point. Okay, so when the price goes down, now they're going to get more marginal utility per dollar from the coffee. And so then as a result, they'll buy more coffee. And then the opposite, if the price goes up, so the price was $4 for coffee, and now if the price of coffee goes up to 6, now that fraction will become smaller. They'd be getting less utility per dollar from the coffee, and then of course they will buy less coffee. All right, any questions? Good, okay, so we've got one more exercise to do, and then we're going to do a little bit of chapter 11. Okay, so this is the pizza apples example again, and we've got the $24 and the prices, this is all the same as before. And we've got all the information that we came up with before about the different bundles, and now we've got different amounts of utility as well for each of the different amounts of the goods. Okay, so what we're going to do is calculate marginal utility per dollar. So we'll start with pizza. So we're starting here at 0. So the first pizza gives 20 units of utility and costs $3. So 20 over 3, so say 6.7 units of utility per dollar. The next pizza is 18 units of utility and costs $3. 6. And then 38 to 54, that's 16 units of utility. Costs $3. It's 5 1/3. Next one is 14 units of utility. All right. So yeah, so the numbers will keep getting smaller, of course, because the marginal utility is falling, but the price stays the same. Okay, so then we'll move on to apples, and I'm going to start at the bottom with 0 apples. So the first 3 apples give 27 units of utility, and we're going by threes here. Apples are $1 each, but that's a change of 3 apples, so 3 times $1. So those will cost $3. So 9. Okay, and then the next 3 apples increases utility by 24, right? 27 to 51 would be 24, and those 3 apples cost $3. All right, next 3 apples, is that 21 units of utility. These are all whole numbers. 15. Okay, now before we do the last column, let's look at these marginal utilities per dollar and see what bundle they would want to choose. And what you can do is, now we're looking for the equilibrium, but usually there's not going to be an exact equilibrium. So we can see that we don't have any numbers that match exactly here. The closest we're getting is here. Now, what you can do is think about it though. So what's happening is the consumer is having to make a trade-off between the pizza and the apples, and they're going to choose whatever one gives them more utility per dollar. So in the trade-off here, 6.7 versus 2, obviously this one's bigger. In the trade-off here, 6 is more than 3. And then 5.3 is more than 4. But then once we get to the next set of numbers, now the apples are giving them more utility per dollar. 5 is bigger than 4.7, and 6 is bigger than 4, and 7 is bigger than 3.3, 8 is bigger than 2.7, 9 is bigger than 2. Okay, so where we cross then, that's where the equilibrium is occurring, and that's at bundle D. Okay, so they would like these pizzas only up to a quantity of 3 pizzas, because those 3 pizzas are giving them more utility per dollar than what they'd give up for the apples. But then they wouldn't want any more pizzas. After that, they'd want the apples, because then the apples give them more utility per dollar. Okay, so bundle D then is where there would be a close equilibrium anyway. Not quite, but close equilibrium between the 2 numbers. Okay, so then last thing is the column on the far right, which is total utility, and this will be for the bundle, for the pizzas and the apples together. So you're looking then at these 2 columns, and you're adding together the 2 total utility numbers. So 0 plus 132, 20 plus 126, 38 plus 117. Okay.